complex which shows maximum magnetic moment is. We have 4 complexes here. We need to calculate what is the maximum magnetic moment. Magnetic moment mu is given by the formula square root n plus 2, where n is the number of unpaired electrons. So, if number of unpaired electrons is more, then mu will be more. So, rather than calculating mu, it will be simpler if we just calculate how many unpaired electrons are present. N is present. Coming to our first formula here, water is neutral everywhere. In this case, of course, we have chloride. So, this is having charge 0. Overall charge is plus 2 and hence chromium must be in a plus 2 oxidation state. Chromium's atomic number is 24. If we remove 2 electrons, then we have 22. Therefore, considering argon's 18 electrons, that is the configuration till 3p, that means 3d has 4 electrons remaining. These 4 electrons are distributed between T2G and EG. T2G comes lower and EG comes higher. Now, water is a weak ligand. In fact, all these A, B, C, D options have weak ligands. Therefore, delta O is not much and pairing is requiring more energy. We won't prefer to pair up electrons. So, the first, second, third electron go to T2G. The fourth electron goes to EG, giving us a total of 4 unpaired electrons. So, N is equal to 4. Considering example option B, chromium here is in plus 3 oxidation state. Chromium is 24 and if we deduct 3 electrons, then we have 21, giving me 3d3. This tells me that this 4th electron in EG is not present. Only 3 electrons are there in T2G, just giving me 3 unpaired electrons. Coming to option C, Mn here is in plus 2 oxidation state. Mn's atomic number is 25. If we remove 2 electrons, then it has 23 electrons. So, 3D contains 5 electrons. Once again, trying to put it in T2G and EG. Again, as water is a weak ligand, the electrons first occupy T2G as well as EG singly, giving us 5 unpaired electrons. Coming to last example, cobalt here, because chloride is minus 4 and overall charge is minus 2, cobalt is in plus 2 state. Atomic number of cobalt is 27 and removing 2 electrons we get 25 and therefore in 3D now we have 7 electrons. Let's place these. 5 electrons have already been placed here in T2G and EG. The 2 more extra electrons has to be paired up. If we pair up like this, then you can see that N here is equal to 3. The number of electrons is only 3. Comparing the values, we can clearly see that option C, which has 5 unpaired electrons, will be having the highest maximum magnetic moment.